First of all, take a quick look at trig quiz number 2, the one that I just gave you. Okay. Number 1 says convert to radians. Leave your answer as an exact value in terms of pi. In other words, 300 degrees is something pi by something. Negative 120 degrees is something pi by something. Number 2 says convert the following angles to degrees, 1 mark each. Then, number 3 is sketch the following, 1 mark, and then tell me the reference angle, 1 mark. So we're in radians. We're in radians. There's a back page to the quiz. So number 4 says, given theta equals 4 pi by 3 radians, find 1 positive and 1 negative coterminal angle. This is right from the homework on radians. And then number 5, now we're going to solve a trig equation. However, for number 5, you're going to need to make sure your calculator is in degrees, because I want my answers in degrees. The other way that you know that you need to be in degrees, as I told you, I want you to find the angles between 0 and 360 degrees. And this is where you're going to use the cast rule, reference angles, and all that stuff. And there's going to be some of that on your trig test. Okay? Today, we're going to continue looking at trig graphs. Click. Starting off with some review. So far, hopefully, we have learned the following. What does sine look like? So far, and this is what you want to memorize for your test. Sine looks like this. Sort of like the letter S. It has a top half and a bottom half. Both halves have the same length. Another latecomer. Other stuff, folks, I need you here. Other stuff about the sine graph. From here to here is 1 period. And I know that the period of the sine graph is 2 pi or 360 degrees. Okay? Which means, what's halfway right there? Either pi or 180 degrees. Now, the highest sine gets is positive 1. The lowest it gets is negative 1, unless we put a coefficient in front, but Sean, to change the amplitude, but I don't have anything in front of the sine, okay? In fact, the highest it gets is right there, and the lowest, the midpoint, the maximum and minimum are right there. And I can even tell you where those occur. What is that in degrees? Do the arithmetic. In degrees, do the arithmetic. This would be 90 degrees, or pi by 2 radians. And this is halfway between 180 and 360. This is 270 degrees, or 3 pi by 2s. 1 pi by 2, 2 pi by 2s, 3 pi by 2s. That's the sine graph. And that's what I have memorized, although, Jordan, full disclosure, I haven't memorized all of it. I know it's 1 high and 1 down, which is pretty easy for me to remember. I know that it's 360 degrees, or 2 pi, which is once around the circle, which is also fairly easy for me to remember. And then I know the shape. Once I do that, I can figure out that that's pi because it's halfway, and I can figure out that that's pi by 2 because it's halfway to pi, and I can figure out that it's 3 pi by 2 because it's 1, 2, 3 of those. So I almost always just derive those in 1 second. Whenever I reteach trig, I rememorize all the details, but if you ask me in the middle of the year to sketch a sine graph, you'll see me draw an S, label it 360 or 2 pi. I'll say, what do you want, radians or degrees? And then you'll see me put in all the halfway points. That also lets me answer amplitude, 1, period, 2 pi, or 360 degrees, depending on which one you want. Midline is y equals 0. It hasn't been moved up or down. And the range, it's between, now, in English we say this, right? It's between, don't write this down, -1 and +1, touching each. That's too much writing. So how do we write that down? First of all, it's a range, is that x or is that y? Because I asked you to. Is that x or is that y? Why? Because I'll never get tired of that joke. That may be the last time you guys hear it in your high school careers. But why? Because I asked you. Why? Because Sean just figured it out. Hey, at least he did. It's y. And to show that it's between -1 and +1, I put a -1 there and a +1 there. Okay? Now, to show that it's between, what I really want to show is that the graph is bigger than -1 and smaller than +1. Bigger than -1, smaller than +1. It's less than. And touching. Okay? Cosine is almost exactly the same, except the shape is different. The shape is different. So it says sketch cosine. Okay. Cosine, I have trouble drawing from scratch. I can do, don't write this down, I can do the S for sine pretty good. Cosine does kind of that shape, but I always botch it. So what I usually do to do cosine is I say, hey, I know that it's 2 pi or 360 degrees. And I know that cosine starts at 1 and it goes down to -1. So I try and make those the same length. What's that right there as an x value? Do the arithmetic. Brooke, how far from here to here? Two pi. So how far from halfway? Yep. Or 180 degrees. And then, Rosanna, I usually pause there because I know the cosine graph, it's at the top right there, and it's at the bottom right there. That's a little low. Right there. Can you sort of see it's going to be that shape? I can fix it better than that, but it's going to be that shape. Oh, not only that. Jordan, what value is that right there? Pi over 2. Or 90 degrees. I know that cosine is 0 right there. Where sine is at the top, cosine is in the middle. And where sine is in the middle, cosine is at the top or the bottom. Oh, and I can use the same trick right here where I have my 3 pi by 2 or my 270 degrees. I know that cosine is in the middle. And now can you see kind of the full shape? I hope. It's going to be... Yes, the tongue helps. Kayvon, this is how I sketch these two. Tangent's the ugly cousin. I'm not going to freak out about tangent. But if you're looking for kind of, I won't call it an easy way, but a straightforward way to memorize the key details of both sine and cosine, there it is. Oh, and I think I've said to you, sine looks like an S, S for sine. And if you turn your head sideways, cosine sort of looks like a C. Kinda. Sorta on its side. Caitlin's squinting. Yeah, I know. You got to use your imagination, but sort of. Oh, here's the nice thing, though. Same amplitude, 1. Same period, 2 pi or 360. Same midline, y equals 0. And same range, -1 less than or equal to y less than or equal to 1. So far, so good, yes? Okay, next page. We've also learned that for y equals a sine bx plus d, for sine and for cosine, we've learned that the number sitting where the a is, hey, what did the number in front of sine and cosine affect from last lesson? Do you remember? And there was a convenient way to remember it because we use the letter a to remind us what it affects because that word begins with a. Amplitude. And the number sitting where the d is, the plus thing, that affects the midline. So let's put it all together. It says sketch 2 full periods of y equals negative 2 cos x minus 2. Draw a nice big long line. We're back? How many periods does this want me to graph? 2. So you know what? If I want to, what was 1 period? 2 pi. What would 2 periods, how long would that be then? 4 pi. So you know what? Let's extend this line a little bit. And how about way over here, let's put 4 pi. We'll do this in radians. Two full periods, 4 pi. So, Sean, right there, halfway, what's that? Good call. And halfway, what's that? Good call. And right here, what's that? Good call. Now, I've also always divided the pi's in half. I'm going to put hash marks there, but I'm not going to label them with numbers because this graph's going to get too crowded. So I'm going to go dunk, 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 dunk. But I'm just not, by the way, the first hash mark, every hash mark is pi by 2. So it's 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, 7 pi by 2. I can fill those in if I need to, but we're good. So far, so good, Cole? Okay. Now let's actually look at the equation. What's the midline that they gave me? What's the midline that they gave me? And you know what? I'm going to change this just slightly. Instead of a negative 2 right there, can you scribble that out? And let's put a minus 1 right there. The reason is I'm worried you'll get the 2 in front confused with the 2 at the back, and I want you to see the difference. I just realized I made up a bad example. So scribble out the minus 2 and make it a minus 1. So what's the midline? Minus 1. What's the amplitude? 2. Okay? What's the negative? Well, that's going to flip the graph. We'll talk about that. But for now, midline is minus 1. You know what? I'm going to do this. I'm going to put a hash mark at minus 1 right about there, and I'm going to do a dotted line. That's the midline. That's the center of this graph. What's the amplitude? 2. So from that midline, I'm going to go 2 up, which is going to be 1, 2 to positive 1. I'm going to do a little dotted line right there. What's the amplitude? 2. From the midline, I'm going to go 2 down. Negative 2, negative 3. I'm going to do a dotted line right there. Okay? Don't write this next, draw the dotted line. Don't write this next bit down. What I'm saying then, Justin, is this graph is going to bounce between those 2 lines. There's my railings. And it's going to be centered at the midline, which is negative 1. I've got the graph in the wrong place, so don't draw that red graph. But can you see, this is what we're talking. This is why if I know the midline and I know the amplitude, really what they've told me, Brooke, is the upper and lower railings that this graph is going to bounce between. Is that okay? Yeah, is that okay? Okay. Last thing I say is, hey, which trig function did they give me? Cos, negative or positive? Negative cosine, positive cosine starts up high. If it was positive cosine, my first point would be right there. You said it was negative cos. My first point, and I'll use red, and you can draw this, is going to be right there. How long is 1 period? How long is 1 period? So at 2 pi, I'm going to be back to where I started from. I'll be back at the bottom. And at 4 pi, I'm going to be back where I started from, back at the bottom. What about, don't write this down. What about halfway? That's when I'm going to be on the opposite end. Now, normally I'd be at the bottom, but because it's a negative cosine, I'll be on the top. In other words, right here and right here is when I'm also going to be touching the upper railing, the upper guideline. Right now, don't write this down, I think the graph's going to look something like that, but not quite. I can do better. Because, Foster, halfway between the bottom and the top, right here, is when I'm also going to be in the middle. And I'm going to be in, now the middle is not the x-axis. The middle is the midline, and that's why I've always used the term middle. I've never said on the x-axis. Middle is the midline. I'm going to be in the middle right here. I'm going to be in the middle right here. I'm going to be in the middle right here. Jake, that's okay? Yeah. You with me? It's going to look there is 2 full periods of -2 cos x minus 1. That's kind of, for those of you that were away last class, a review of what we did. Is that okay, Rosanna? Or you have a question? You okay, okay, okay? Now, here's the question we're going to ask now. What does the parameter b do to it? What does sticking a number in front of the x inside the brackets do? So get out your graphing calculator. Put yourself in radians if you haven't already. I am in radians. And go to your graph menu. First thing, change the window. Make your x min 0, your x max 8, scale 1, and your y min -2, your y max 2, scale 1. So change your view window. Do that real quick, please. The window's right there. X max scale, Y min, Y max scale. So for those of you that are looking up, you have it in front of you. You don't need to be squinting up at the board here. Right? This is how we draw this. This is how we draw view windows. Okay? Once you have that, everybody have that? Okay, Brooke, we're there or no? It's min, max, scale, min, max, scale. Okay, okay. I'm going to be doing that a whole bunch, so we want to get fast at that. I won't have to spend 2 minutes just waiting for the view windows. We're going to have to adjust the view windows quite a bit. And now let's graph this. So go to your graph menu and type in sine, and you have to put a bracket. 2 pi, which is shift exponent, divided by 4, and then times x. 2 pi by 4 times x, which is what I have written here, 2 pi by 4x. When I typed it, I didn't have to put the times sign in, but I think you have to put a times sign on your graphing calculator. And hit draw. You hit draw? You need to participate here, folks. The equation is right in front of you. You get this? Here's what I want you to notice. What's the period? Okay, people are still trying to graph it. Okay? Let me know when you got it graphed, then look up. Are we there? Are both of you there? Well, okay? Everyone look up, please. The period is from the top to the top, or from the bottom to the bottom. How big is the period? Let's see. Starting here, it goes 1, 2, 3, 4. What's the period of this graph? Not 2 pi. What's the period of this graph? Can you see a 4 hidden in the original equation anywhere? I was going to do a sketch in the interests of time. I'm just going to move on. Let's try the next one. Same window, but we're going to graph 2 pi by 6. So if you go exit, and I think you can probably just backspace and edit and delete the 4 and make it a 6. And hit draw. Okay. Now I'm going to count from right here to right here, let's say. It's going to be, oh, yeah, that works, Mr. Dueck. 1, 2, 3, 4, 5, 6. What's the period? Everybody repeat it. Is there a 6 hidden in the original equation anywhere? Oh. Spotting the pattern. Next page. What's the period of this graph without graphing it? Okay. Now we're going to do a sketch without graphing it. What are we graphing? Sine or cosine? Okay. What's the period of this graph? Not 2 pi. What is it? So all of you put a 2 right there. What would that be? See where I'm going? What would this be? 0.5. What would this be? 1.5. Is there a number in front of the cosine? Have we changed the amplitude at all? No? So then the amplitude is going to be positive 1 and negative 1. It's going to go up 1, down 1. Which trig function did they give me, sine or cosine? Negative cos or positive cos? Starts up high. The first point's going to be right there. What's the period of this one? 2. So the second, it's going to be at the top right there again. Where's it going to be at the bottom? Halfway. Right there. Where's it going to be in the middle? Halfway to halfway. Right there and right there. It's the same shape as we started out drawing with cosine, but the period has changed. But Brooke, to draw it, I still use the trick of divide it in half and divide each half in half because I know the shape hasn't changed. Going to skip example 4. I'm going to go to example 5. Example 5. What's the period? If I were to sketch this, it's 5 long. What would that be right there? You'll have to do some arithmetic in your head. 2.5. What would that be right there? You'll have to do some decimal arithmetic in your head. 1.25. What would that be right there? You'll have to do some arithmetic in your head. 3.75. Have they changed the amplitude at all? Have they changed the no? And you know where to look, right? I could handle it, but no. So this graph is going to go 1 high and negative 1 high. Which trig function did they give me? Sine or cosine? Sine, you say? Sine starts in the middle. Positive sine or negative sine? Positive, so it's going to go up, and it's going to be that S shape. It's going to be top, middle, bottom, middle. There's one period of the sine of 2 pi by 5 times x. And Caitlin, what I'm really doing is I'm cheating a bit. Here's what I'm saying. Because the shape of sine never changes, it's easier to change your graph paper, put a 5 there instead of a 2 pi, than it is to try and sketch it. I just keep the same S shape, but I just change the, oh, I know how long it is, divide it in half, divide each half in half, divide each half in half. Done. Number 6. What's the period of this one? Sketch it. Okay. How long is one graph? 3. Divide it in half and divide each half in half. 1.5. You know what? I'm not even going to label that. I think it's 0.75, whatever. And that is 2.25, whatever. You updated your Facebook status, Christina? Put the phone away. I'll grab it next time. Hey, which trig function is this one? Cos? Positive or negative? Did they change the amplitude? Is there something in front of the cos at all? No. Then it's going to go 1 high, negative 1 high, and its positive cos starts up high. Then goes to the middle, to the bottom, to the middle, back up high. Hey, what if they said sketch 2 whole periods? Instead of going from 0 to 3, I'd go from 0 all the way over here, which would be what? 6. Divide in half, divide in half, divide the chunks in half. So, given sine or cosine with a number in front of the x, a number in front of the x, b is 2 pi over the period. The period is the number beneath the 2 pi. Is that okay, Kayvon? Yep. You weren't foolishly on your phone and 1 page behind or anything like that, were you? No, you were 1 page behind, though, somewhere. Okay? The number in front of the x is 2 pi over the period. Or, if I tell you we're in degrees, it's 360 degrees over, and I'm going to use the letter P for period. By the way, if b, the number in front of the x, is 2 pi over the period, if the number underneath the 2 pi is the period, then the period is also 2 pi over b, or 360 degrees over b. Say what? Patience. I like this next question. I like this next question. I like this next question. So it says, state the amplitude and the period. Let's, for all 4 of these, A, B, C, and D, let's state the amplitude. And then we'll do the period. What's the amplitude of A? What's the amplitude? 3. What's the amplitude of B? Careful. 2, not negative. The negative just tells you when you're graphing it, start at the bottom. What's the amplitude of C? 0.5. And what's the amplitude of D? Well, just 1. The negative flips the graph. It doesn't change the amplitude. Okay. What's the period? Well, the period is 2 pi over B. What's B? The number in front of the x. What's in front of the x? I've circled it. What's in front of the x? No, the whole thing. The period is going to be 2 pi over 4 pi. By the way, what's pi divided by pi? What's 2 over 4? This graph has a period of 1/2. Not as obvious as the ones that I gave you where the 2 pi was blatantly in the equation, but this is the pattern. The number in front of the x, the period, is 2 pi divided by that number. And it worked great when I had a 2 pi in there, then it was obvious. But even if it's not, hey, what's the period of graph B? The period is going to be 2 pi over what's in front of the x. What's in front of the x? This graph has a period of 2 pi by 3. What's the period of C? Which reduces, what's 2 over 4, 2 pi by 4? What's 2 over 4 in lowest terms? Yeah, this reduces to pi by 2. What's the period of D? Okay? Continue the pattern. The period is 2 pi over 1/2. Now, I can't leave it like that. So, you ready? Time for a Math 8 review. Coming full circle in your grade 12 year. At the end of your grade 12 year. How do you divide by a fraction? Because that's what we're doing. Anybody remember from Math 8? Sean, you're close. Say the first, what'd you say? Something to do with timesing it, but you don't just, because divide doesn't become times. But you can turn it into a times. Ah, this is the same as 2 pi times 2 over when you multiply by the reciprocal. And you know what, Kayvon, I can see you looking a little confused. I'll even put the pi over 1 so I have fraction times fraction. See it? And now it's top times top, bottom times bottom. It's 4 pi over 1. Did I need to write the over 1, Foster? Not really. I like this question. I like this question. I like this question. How do you divide by a fraction? You multiply by the reciprocal of that fraction. So you ready? 2 more, and the homework's going to be from the textbook. Speaking of textbooks, you need to bring them to the final class day. If you do not, listen closely, this is my promise to you, because the block order next week, Monday, is A, B, C, D. I will take your cell phone away for the day until I get my textbook back that day. I have to, because these textbooks cost money. Some of you, oh, the look on some of your faces right now, man, this is, but how will, just bring your textbooks, okay? And I'll make sure during the test that your textbook number matches the one that I signed out to you. Sean, can I help you?
He has to wash his eyes.
You wash your eyes?
No.
I don't, yeah, on the, there you go. They're the good ones with the lotion. How much is left? Still some left?
Yeah.
Okay. I was going to say crank it. There's a phone in there, but it's a casualty of war. Next one. I like this question. I like this question. I like this question. Why would I say that? I didn't say that. Maybe you're good students. You figured something out in grade 12. Ready, Rosanna? Says, write the equation of a sine function with amplitude 2/5 and a period of pi by 3. Okay. It's going to look like this. Y equals it's sine. Roy, what? Okay, amplitude. Oh, and don't forget to put an x in the brackets because I need an x there for it to be an equation. What's the period? What's this question say the period is? Most common mistake, don't do this. Kids go, oh. And if this is multiple choice, I'll have that to pick from. That's wrong. Here's what we said. We said the period is 2 pi over b, and we said that b is 2 pi over the period. And b is the number that's going to go right there. Don't put the b in front there, but I'm just showing you that's the placeholder. Right, Christina? That's what we said. We said b is 2 pi over the period is 2 pi over b. So, if I want to actually get the equation, it's going to be 2 pi over pi by 3. Hey, how do I divide by a fraction? This is going to be the same as 2 pi times... Rachel, you're right. What did you say? Shh. Put your face down in the appropriate block. Sorry, multiply by the reciprocal. So times 3 over pi. Justin, my friend, when you're done giggling, do I have a pi on top and a pi on the bottom here? Yep. And so really what I have is 2 times 3. 2 times 3. Oh. The equation that has an amplitude of 2/5 and a period of pi by 3 is 2/5 sine 6x. B. Is that okay? What's different about B? We're in degrees. How do I know we're in degrees? And even it's not even the 720. It's the degrees symbol says, okay, I'm in degrees. So I'm going to use the same thing, but instead of 2 pi, I'm going to use 360. Okay, so it wants a cosine function. It's going to be y equals, and there's going to be a cosine, and there's going to be an x here. What's going to be in front of the cosine? 4. What's going to be in front of the x? I don't know yet. I'm going to have to do some arithmetic. The number in front of the x, which I've symbolized with a b, is going to be 360 over the period. It's 2 pi over the period when it's in radians. It's 360 over the period when it's in degrees. Hey, what is 360 over 720 in lowest terms? So your homework, you can do this all on one page, please. From the textbook, those questions there, and get the take-home quiz done. I'll be starting next class marking that. But definitely you can expect me to give you some questions on your test where I'm going to either give you the equation and say, tell me the amplitude, the period, the midline. Or I'm going to say, write me an equation with an amplitude of something, a midline of something, and a period of something.